Welcome, listeners. This is Sanjog Aul, your host, and the topic for conversation is the Smart Grid Big Data Challenge. And I have with me Mark Wyatt. Mark is the Vice President for Grid Modernization and Distribution with Duke Energy. Hello, Mark. Thank you for joining us.
Good afternoon.
How are you doing?
Doing well, thank you.
Very good. Now, talking about big data is a huge trend right now, but it was important to talk about in this context because with Smart Grid, figuring out the plan for solving this problem is arguably step number one. And with that said, the question that I'd like to pose right now is what problems are faced by utilities, including transmission, substation, and distribution systems that in theory, big data would be poised to correct? And which factors do you think are the greatest problems than the others?
Thank you for the question. Yes, if you think about the broad ecosystem of the transmission and distribution network that electric utilities are dealing with, most all of the networks across the United States today are fairly aged and are in significant need of replacing, going from a more electromechanical analog infrastructure to a more digitally enabled infrastructure. And today we're operating that system well. We're able to provide good reliability and availability to customers. But the challenge we have is a lot of the data that we get off of the system today before it's digitally enabled is it's either days, weeks, or months behind when we actually get it in from the field to our engineers and other key folks within the organization. By putting the digital technology out on the system, whether it's intelligent transformers, reclosers, capacitors, smart meters, we're able to get more real-time or near real-time information from these various devices to help us improve reliability and availability, give better insight to our customers in terms of how they use our product, enabling them to have more control over how they use our product, when they use our product, to help them manage the personal lifestyle that they look at. It also helps us in terms of minimizing cost on the systems. We have the ability to do a lot more remote activity from a control standpoint and enabling us to get service to customers more quickly and more reliably. And probably the biggest area of improvement is around how we respond to power outages in particular. We're one of the last utilities out there where customers, in most cases, have to contact us as a utility to tell us that their power's out. With this digital capability, we have better insight in terms of when outages are likely to happen, and when they do happen, and can be more proactive in dispatching crews out and getting power restored to the customer sooner and having a more proactive experience. So with this massive amount of data that we're collecting, that's going to enable us to do those things that I have just referenced. The challenge that we have is ensuring that we bring the data back in a timely manner. We know how we're going to use the data, what tools we're going to process against that data, how we're going to enable our engineers, our customer service reps to use the data, because this is a massive amount of data. And if we bring it back in a timely fashion and only bring it back when we need it and there's a value that we see to the utility, to the customer, then that helps manage this overall volume of data that comes in, and it becomes less of a technical challenge and more of how we get our employees equipped to actually leverage and use that data. So while we talk about big data, if you manage it well, it does not become overwhelming, but you really got to have good processes and good tools in place to gradually bring it back as values identified on the system.
Now, while you mentioned about the value it brings, and definitely there's a very strong proof point that it, if implemented properly, will create value. Do you see some areas where people have to be cautious as they go about implementing it when you mentioned process optimization and using the right people, process, and technology, which will actually make it successful?
Yeah, the real challenge is if you go back to my earlier comment that a lot of the data that we get today off of the analog side of our system or the electromechanical side is either days, weeks, or months old. So our employees, our engineers, our customer service reps are used to taking very old data and trying to predict what's going to happen based on older types of data. And so you're being very reactive in terms of how you use that data. The challenge we have now is our processes are not really established or set up to have data coming in on a more real-time or near real-time basis. So our employees are not prepared or well-skilled or well-equipped to know how to actually bring that data in, put analytics around it, and begin to have more near real-time analysis of what's happening. A good example could be as a customer calls in and requests a new service. Right now, it takes us anywhere from 5 to 10 days to make an appointment and set up the appointment to connect that customer service The technology that we're deploying now enables the customer to actually go out and see when we have service connection availability, schedule that appointment themselves, and it does not require a manual intervention, but all of our back-end processes have to be established and set up so that if and when the customer takes the ownership of scheduling that appointment, all of our back-end processes can recognize that so that we get the efficiencies out of it. So it's more about how do you look at all the steps in the process, knowing that you now have that near real-time or more real-time data available versus you're offering off of very old data.
Now, with big data, we know that it is promising effective manifestation and perhaps subsequent optimization to a larger degree of smart grid. But both are fairly young on the maturity curve. So how do you think we can make sure that these two ultimately unproven technologies, or maybe they're work in progress, to some degree meet our expectations in saving us money and essentially deliver the end goal?
I guess my first response would be, if you look at other business sectors, if you look at retail, you look at banking, you look at finance, you look at industries that have really bridged the gap in terms of how they leverage the massive amounts of data that they're bringing into their business to adjust and adapt their business model. I think the tools, the techniques, and the processes that they use are no different than the same comparables that we need to use in the utility. So we reach out on a quite regular basis to other industry verticals outside of utilities to say, how have you addressed this problem? If you had access to more granular, more real-time or near real-time information to begin to help us think about how we manage and process this. You need to have the systems and the tools in place when this data comes back off of the grid, and we have centralized control centers today that are set up to be able to manage and operate against that data. So the challenge for us is, how do you ensure that you're bringing it back on a timely basis, that your algorithms can process it, you can filter only those elements that are important? Because if you think about a substation as an example, you could bring back hundreds of data points every second associated with that substation, but you, in most cases, only need 4 or 5 key points coming back that gives an engineer or a control operator what they need to make good decisions on that. So it's a lot about looking at all the data elements, planning which ones you bring back, making sure the software can process it, and only bring back additional data when needed. So I think a misnomer or kind of a falsehood that we're talking about now is you have to have all of this data coming back before you can make intelligent decisions. In our opinion, you only need to bring a subset of that data back, and as you learn more about that, then you can add additional data elements as you get comfortable with those few that you do bring back.
Now, what sorts of insights? I'm sure you've already listed quite a few, that the kind of insights that you would like to have and how you utilize that for your business purposes. What are the insights that you think someone should look at the top of their list as the one that they should expect to come out of big data? And then what is the tangible hard dollar value that someone can derive from it? What do you think they should be doing? Yeah, go ahead. First, let's look at this question.
Yeah, I would say, and again, I'm looking through the utility lens in particular, there's really 2 aspects that I would say we look at as we're deploying a lot of our grid modernization technology. What data and information can help our employees, our engineers, our line technicians be able to deliver service more quickly, more efficiently, more cost effectively for customers? So that's one dimension. The other one is, if you think about how we interface with customers today, in most cases, customers call us for 2 reasons. One is to initiate service, or 2 is they have an issue or a problem. And that issue or problem is either their power is out or they have a question about their bill. And so if you think about the customer-facing piece of it, let's talk about that first. The real value for us is giving that customer a more real-time view of how they're using energy on a daily, weekly, monthly basis. That helps them in terms of planning for how much money they need to budget to pay their bill. They may need to want to do more efficiency things in the home, so giving them good consumption information, time of day, and providing it to them when they want it and where they want it. Do they want it on a mobile device? Do they want it on a laptop? Do they want it pushed to them? Do they want to go to a site to pull it? So it's really around consumption information, weather information, things about what's happening on the system. So that really helps them get in better control. When you go back to the internal side of the equation, the value that we see is, as we're looking to optimize the operation of our system, we have a certain amount of energy or electricity that is generated by our baseload power plant every day, every morning, every week. And if we can look to how we optimize the distribution system to take that energy into the grid, we can more efficiently bring that energy and supply it to the customer when they need it. We also can do reliability improvements. We spend a good bit of capital and a good bit of operations and maintenance expense on asset management, maintaining our assets, maintaining reclosers, capacitors, transformers, and substations. So if we can see the history of how that piece of equipment operates, we can better levelize and predict when we need to do maintenance on those assets and dramatically reduce the cost of having to send folks to the field to look at and doing more predictive maintenance. And also it reduces the cost of the capital to actually have to go out and replace some of those devices. So it helps on the efficiency side as well as giving the customers more transparency. And at the end of the day, it's all about cleaner, more cost-effective energy that we deliver to the customer.
Let's take a quick break, listeners. We'll be right back. And then let's look at any proof points that we may already have that big data could actually be a success in terms of ROI or it has actually helped improve operations for a utility on either side of the meter. Please stay tuned. We'll be right back.
The U.S. and Canada represent just 5% of the global population, but collectively we consume about 35% of the world's resources. Supply is not keeping up with demand, so change is not an option, it's imperative. Siemens brings knowledge to power through modernization, responsible energy consumption, and greening the grid projects. Siemens Smart Grid has the answers. Just Google Lead the Charge portal.
You are listening to CIO Talk Radio Viewpoint.
Welcome back. So, Mark, again, what proof points do you think we already have with big data that it is a success in terms of ROI and or improving operations for a utility on either side of the meter?
Great question. Let's talk specifically about the data that we're able to get from these smart meters today. If you think about where we've come from in terms of meters and the available information, most utilities today have two types of meters that they have installed at customers' homes. One that's purely an electromechanical analog meter that you have to have an individual go out and read that meter to be able to get the information needed to bill that customer or to look at voltage issues, look at reliability issues at the premise. Second evolution is something that we call an automated meter reading, where you go out and you install a meter where you have a one-way communications mechanism where you can drive by and use radio technology to read that meter, basically getting the same data associated with what you would get when you go by and manually read that meter. And so what you're doing is you're getting an efficiency in terms of how you're actually reading the meter, reducing labor costs, and improving the predictability and timing of getting an accurate read. So while those have served us well and we've been able to give accurate reads to customers, now that you have a smart meter out there, we can actually go out and read that meter on whatever frequency we want to. We could read it every 15 minutes, we could read it every hour, we could read it once a week, or we could read it once a month. I think that's a very important thing to understand. While the meter is capable of being read on a very timely frequency, you need to understand the business processes that you need to put around it to leverage that data. If you bring back 15-minute interval, let's say 3 channels of data on a 15-minute interval for a typical population of about 100,000 meters, can you multiply that over a year's period of time? That's the same volume of data that we have historically collected on about 4 million meters. So the approach we've taken is says let's only bring back the data that we need to accurately bill the customer, to accurately give the customer insight into terms of how they're using their energy, can also give us the ability to remotely connect and disconnect that meter as customers want to move in and move out. So through the meters that we've deployed, in the jurisdictions that we deployed them in, we have seen substantial reductions in labor costs associated with reading meters. We have improved the reliability and predictability of getting a bill out on time and an accurate bill. We're no longer estimating bills. In one of our jurisdictions, once we're fully deployed with all of our automated meters, we will eliminate approximately 1 million estimated bills a year. That means there's 1 million bills that will go to the customer where they will have an accurate read, an accurate account of what they owe us, and that makes the conversation between us and the customer that much more predictable. They also can go out on our portal every morning and see their previous day's usage, and they can track that over whatever period of time, and they can interact with us if they have questions about how that's done. So that's improving the relationship with us and the customer, reducing the number of reactive calls that come to our call center. Last but not least, when the customer wants to move in and move out of a particular facility, if you'll reference a previous response I gave you, sometimes it takes 5 to 10 days to schedule and do that connect or disconnect. Now that customer can go online, call a service rep, and within whatever period of time they want to have the connection and disconnection, we schedule it at their convenience. We no longer have to send a tech out, and that meter can be connected and disconnected literally within a 15 to 30 minute period of time. Your satisfaction goes up. We're reducing labor costs by not having to go out and read that meter. So if you multiply that times the volume of meters and reads that we have, without getting into specifics, you get real hard dollar savings and you get customer satisfaction that improves dramatically.
While we say that, of course, there's high volume transactions that and number crunching we have to do and reporting we have to provide and timely input provided to everyone, including customers and internal operation team, definitely big data is promising great results. When it comes to mission critical decisions, do you think we are at a point where big data can actually be trusted because things could go wrong at the time of collection of data and then into processing and finally at the interpretation stage too?
Great question. I guess the short answer is I think, yes, we are well positioned to do that. Once you get enough volume of new infrastructure deployed, let's say a critical mass of smart meters or a critical mass of distribution automation devices, where you're actually able to start collecting the data on whatever frequency you need to. If you think about the technology enablers today, whether it's the hardware, the software, the telecommunications network, we have the raw processing capability and the power to bring that data back on a very timely, reliable basis. Do you need 5 nines of reliability on the data? Do you need 4 nines reliability? At least from the Duke perspective, on a telecommunications side, instead of us continuing to build out our own private networks, we're relying on publicly available networks like AT&T and Verizon. So we're leveraging those networks and they have a high degree of reliability. The real key is how often and how soon and how quickly you need to bring that data back. If you schedule it appropriately and then you bring it back in and you have it aggregated, it helps us better predict where we're going to have load growth issues, where we're going to have peaking issues on the system. And so we can bring this data back, give it to engineers, give it to planners, and they get the full sum effect of what's happening on the system. The other real key to us, and we're not there yet, the system is able to do it, but we've got a culture change around it, is a lot of the tools that we use today when we go build out a new piece of infrastructure or we go put a meter on a customer's home, a lot of that work, we have automated systems to capture the activity and come back and include it in our system. But there's a natural delay based on human interaction in each step of that process. This equipment can self-discover. We know when a meter is set. We know when a transformer is installed. If you think about the analogy of when you get a new cell phone, when a cell phone comes in from whatever provider that you have, you get instructions to tell you how to activate that cell phone, transition it to a new plan. These systems have the ability to self-discover and bring it back into our base system so that you take the human interaction out of it. So what you do is the quality of our data improves. We take out a lot of that manual interaction. But then again, you've got to be very mindful. Big data is not as big as most people think. You can bring back hundreds of thousands of points, but you need to limit the points that you bring back when there's a business value to use it. And if you do it well, it does not overwhelm your system. It does not overwhelm your employees. And you have a much higher probability of getting value out of that data.
Now, one final question, with all the concerns and questions, and of course, successes all combined, how do you think big data and or utility challenge are supposed to compound, and how are we supposed to keep ourselves at par or at least running at the race at the same speed as these things are changing around us?
Some of this will be a little bit of a repeat of just some things I've already mentioned, but while a lot of the capability or a lot of the technology we're deploying today has the ability to bring back large volumes, massive volumes of data, the key is only bringing that data back when you need it and leveraging it when you need it. I think a lot of companies, a lot of entities, utilities, non-utilities say, let's bring all of it back. And we'll figure out over time how we leverage it. And that overwhelms the IT department, that overwhelms the CIO. They're busy trying to bring back and manage terabytes, petabytes of data. And my history tells me, at least in the utility and some of my peer areas, less than 5% of that data is ever truly used. So you bring back a massive amount of data. There's expense associated with processing it. You're overwhelming the system. Your employees and the users of that data don't know how to filter through it. So it's more about putting discipline up front in terms of telling me what data you need, how are you going to use it, who's going to pay for it, how are you going to turn it into useful insights. And experience says, once you do that in a very deliberate fashion, you'll pick momentum up and then you'll start bringing back more and more of that data. And if you plan it that way, it is not as big of a challenge to the technology organization is more of a challenge to the business organization to say, how do I turn that into real value? So I really hope that we're starting to balance the conversation around big data. It's not as scary as most people think it is. If you put good, solid business discipline around it up front, you can manage both the technical and the business side of it, and it will not be nearly as difficult as most people lay it out to be.
Once again, thank you, Mark, for sharing your thoughts and insights about the Smart Grid Big Data Challenge.
Thank you.
And listeners, I invite you to find more conversations about Smart Grid on our website at www.ciotalkradio.com/smartgrid.